In this video, we'll look at integrals that will involve logarithms. So the last section, we talked about the derivative of logarithmic functions, and so we got this result. The derivative of natural log of x was 1 over x. Now, if the derivative of log x is 1 over x, then the antiderivative of 1 over x should be log x. Now, it's actually slightly more complicated than that, and this is really going to irritate you guys. The antiderivative of 1 over x is not just log x, and of course plus c. It's actually log of absolute value of x. And there's a bunch of technical reasons why this is the case, but essentially the idea is this. 1 over x as a function has domain everything but 0. Log x as a function has domain everything that's positive. And so if you take the derivative of log x, well, you're already assuming that the x is positive. And so this 1 over x is actually technically only valid for x positive. So, however, with this integral, the original function that we start with 1 over x is valid for x non-zero. And by putting the absolute value here, we make it so that this logarithm is defined only, or provided that the stuff on the inside is not 0 or negative. The absolute value is never negative. It could be 0, and that happens only when x equals 0, which is exactly when this function's over here isn't defined. So the absolute value sort of fixes it so that these guys have domains that sort of match up. The absolute value is very important, and you will lose points if you don't put it, so don't try that. Okay, so let's look at a quick example of this. So let's say that we had, it's the worst looking integral sign ever. Try again. Let's say that we wish to do the integral of 1 over 7x plus 2 dx. Now this looks suspiciously like 1 over x, but it isn't quite in that form. And so to make it in that form, you might have guessed, let's do a u-substitution. So let me let u equal 7x plus 2. Therefore, du is 7 dx. And I've got the dx, I just am missing the 7. So I'm going to do the standard trick of putting the 7 that I want in and taking a 1/7 out to make up for it. Okay, and now I can make the substitution. So this is du over u. And the integral of dx over x is log x plus c, so the integral of du over u is log u plus c, with the absolute value, of course. And then all we have to do is replace what was u. It was 7x plus 2. And that's it. So this is sort of a quick, good review of u-substitutions. We needed that here. We'll look at more exotic integrals than this one in class. But for now, the moral of the story is don't forget the absolute value. And on WebAssign, you can get the absolute value by using the palette tool to do that. So just make sure you don't forget the absolute value, and you should pretty much get it.